Now after the Cartesian products, now we are on relation, okay, and after relation then we are going for the function. Now basically we have gone through the ordered pairs, and what we realized there that when we are writing, I just gave you an example for the country and the currency. So when we are writing the ordered pair and the first component has some relation with the second component, then we are saying that that ordered pair is not basically an ordered pair, it is a relation. That's what in the relation is. So okay, so now first of all let's go with an simple example. Now example, yesterday I gave you for the country and the currency. Now just look here what I am writing here. Now let capital N be the set of natural numbers. Capital N be the set of natural numbers. Now I am writing here set A and the ordered pairs 1, 1, 2, 4, 3, 9, 4, 16 and so on. Okay. Now when you are looking towards the ordered pairs, now can you have any type of thinking that what relation is with the first one and the second one? So we can easily think that first component is the, or sorry, second component is the square of the first. Okay. So this means it is having some relation. Okay. Now what we can write it here now, the relation in set A will be, now what the relation we can write it, the relation will be has as its square, let it be like this. Now why I have written has as its square, because we are just going from the first component to the second component. Okay. Now here, now if we are writing now, the term relation will be written by capital R. Okay. Now if capital R denotes the relation, then we can write 1 capital R 1, 2 capital R 4, 3 capital R 9, and like this we can continue it. Is it clear? Now once again we can write it set A as 1, 1, 2, 4, 3, 9 and so on. Then this also we can write it as x, y such that x and y both belongs to natural number and y is equal to x square. Okay, like this one, or y is equal to x square. Now what we have done it, we have written in the roster form and set builder form. Okay. Now let's move for the definition part. Now definition. And capital R, which we have used as a relation here, this is basically the notation for the relation. Is it clear? So now a relation is a set of ordered pairs obtained by virtue of an association between two sets. any set of ordered pair is a relation. Okay, any of the set, whatever it is, we can say it is a relation. Okay, now the first component is always called domain, and the second component is called range. Okay. Now, the first component, it is always called domain, and the second component is always called range. Okay. Now, the notation x r y. Okay. Now, the notation x with a capital R, y. Now, here R means what? It represents some relation. X has some relation with y, or y has some relation with x. Okay. So, the notation x comma y, x is the relation, x is, now this is means x capital R and y, we are just saying that what we are going to set it, this is, or what we are going to read it as, x is the relation R to y. X is the relation R to y, or x comma y belongs to R, which implies x r y. Is it clear? So, this is what basically a definition, and explanation we have already gone with the example in the beginning.